Hello guys, so in this video we're going to talk about how to find the angle between two vectors, a vector A and a vector B. And basically the idea is that these two vectors are touching each other, but there's an angle between them. So the vector would look something like this. Is a 3D space. The vector would look something along the lines of like this. So we have a vector going this way, we have a vector going this way, and this theta is the angle between them. And this is a three-dimensional graph, so z, y, x. So something like that. That's what your vector looks like. Now, the computation is very easy. But if you picture in your head, you know what's happening. So basically, the idea is that we have a formula right here, which is given to us as cosine theta is equal to A dot V divided by magnitude A times magnitude B. So without further ado, we identify our vector A and our vector B, which are these right here. So the first step is we find the dot product of A and B. A dot B, the dot product. I'll put it in parentheses. So in doing so, to find the dot product, we simply just compute. We multiply each element by its respective counterpart. So A is 2, 4, 1. Dotting it with B is -5, 7, 6. And then whenever we dot these, we get -4. We're dotting it with this one right here. 2, we're going to dot it with this one. And 1, we're going to multiply it with this one. So 4 times -5 plus 2 times +7 plus 1 times +6. And this will give us a number, so we'll get -20 plus 14 times 6. So we get, oh no, this is +20, sorry. So +20 plus 14 plus 6. So we get 40. So now we have our dot product. And I'm going to put brackets around it because we are going to come back to it later. The next step is to find magnitude A. Find. Whenever you see this double bar notation, it means magnitude. So I'll go ahead and put that in parentheses. So we're trying to compute the magnitude of vector A. So how do we do that? Real simple. We just take the components of A. So 4, 2, and 1. We square them and then we square root them. So 4 squared plus 2 squared plus 1 squared inside a square root. That would be the magnitude of vector A. And in doing so, when we compute this, we get 16 plus 4 plus 1 is 21. So we get the square root of 21. The next step would be to compute the magnitude of vector B. So we're going to go ahead and do that. So we're going to find the magnitude of B. And always use this double bar notation for magnitude because single bar notation is absolute value, but double bar notation indicates magnitude. Whenever you're presenting your work, you don't want to have any ambiguity, so that would be my route. So the magnitude of B is equal to -5 squared plus 7 squared plus 6 squared, all inside a square root. And then the magnitude of B is equal to 25 plus 49 plus 36. So that would be 25 plus 49 would be 74. 74 plus 36. So that would be exactly 100. Am I off? Yeah, I'm off. It's 110. Yeah, so 25 plus 49, 74. 74 plus 30, 104 plus 6. Yep, 110. So now that we have this, the next step is to plug them into the formula. So basically right here, we are given this formula. Cosine theta is equal to this thing. So now we have all the components. We have the magnitude of B. We have the magnitude of A, which is square root of 21. And we have the dot product, which is 40. So now cosine theta is equal to all that. A dot B, which we have, divided by magnitude A times magnitude B. So to get the angle, it would be the arc cosine, or the inverse cosine means the exact same thing of these values. So when we plug this in, we get theta is equal to inverse cosine. I changed notation, but it means the exact same thing of, what was our dot product? Our dot product was 40 divided by magnitude A was 21. Magnitude B was 110. Oh, 110. And then you plug this into your calculator, and then when you plug this in your calculator, you get the angle between two vectors. And in this case, the answer should come out to be 33.67 degrees. And that is how you find the angle between two vectors. So looking back in retrospect, we have this formula right here, right? So the first thing we do is we find the dot product of A and B. We found that to be 40. We multiply element by element. The next step is to find the magnitude of A. So we take the components of vector A, which we did right here. We square them, add them together, take the square root of that. We got the square root of 21. The next step is to take the components of vector B, find the magnitude, so we do the exact same process. Square them, add them, square root. Then we apply this formula to get the angle. And in this case, our angle was 33.67. Thank you for watching. I hope that was helpful. Hello guys, so in this video, I'm gonna go over how to find the angle between two vectors. So whenever we're trying to find an angle between two vectors, we have two vectors that look like this. So I'm going to quickly draw the coordinate system. This is our Z, this is our X, this is our Y. And basically, we have a vector going here in three-dimensional space. We have another vector going here in three-dimensional space. And finding the angle between those two vectors is what this computation does. So we have cosine theta is equal to A dot B divided by magnitude A times magnitude B. So without further ado, the first step is to find the dot product of A and B. So find A dot B, parentheses, I'm going to put in dot product. Okay. So how do we find dot product? If you don't know how to find dot product, I have a video on that, but it's very easy. So basically, we're just going to take the components of each, multiply them by each other, and add them together. So our A, so basically, A dot B is equal to A. So it's 4, 7, 3, dotted with 3, 1, 2. So whenever we dot these, we just take each component, multiply it, and then add it. So without further ado, so 4 times 3 plus 7 times 1, because it's a y component. And then we take the last components, plus 3 times 2. And you can only take a dot product whenever they have the exact same number of rows and columns. So in this case, 1 row, 3 columns, so we can take it. So then we add them together. So we get 12 plus 7 plus 6. So this answer would come out to be 31. Wait, no, I'm off. 25, sorry. 25. Yeah, 12 plus 6 is 18 plus 7 is 25. Okay, so this right here is our dot product, is 25. So then the next step would be to find the magnitude of vector A. So find the magnitude of vector A. So notice how I do have two bars around it instead of one bar. One bar is absolute value, 2 bars is magnitude. So make sure you don't confuse those notations, because presenting your work is always a component to whenever you're being graded for an exam, or whenever you're trying to have someone else follow your work. You want to make sure you have the right notation. So 2 bars is magnitude. So in this problem, we're asked to find the magnitude. We're asked to find the angle between two vectors, and in order to do so, we need to find the magnitude of A. And if you don't know how to find magnitude, I do have a video on that, but it's really easy as well. So we basically just take the x, y, and z component of vector A, we square them, we add them together, we take the square root. So for example, so the magnitude of vector A is equal to 4 squared plus 7 squared plus 3 squared. And the square root. So whenever we add these numbers together, we get 16 plus 9, 25. 25 plus 49, 74. And that's the magnitude of, so the magnitude of vector A would be the square root of 74. And so now we have our dot product, and we have our magnitude of vector A. But to solve for theta, we still need the magnitude of vector B. So we basically apply the same thing. So the next step is find magnitude of vector B. So to find the magnitude of vector B, we apply the exact same process. So the magnitude of vector B is equal to 3 squared plus 1 squared plus 2 squared. Whenever we compute this, we get 9 plus 4 plus 1. So that would be the square root of 14. And now we have our x, y, and, we have our A dot B, we have our magnitude A, and we have magnitude B. So now the next step is to solve for theta. So we do this by taking this formula and we solve it for theta. So we know that since this has cosine on it, we use algebra and we take the arc cosine on both sides, and we'll be left just with theta. So theta is equal to the arc cosine, or the inverse cosine, it means the exact same thing, of A dot B divided by magnitude A times magnitude B. So now it's just a matter of just plugging in what we have. So theta is equal to inverse cosine. I changed the notation, but it means the exact same thing, of the dot product of A and B. So we find that. What do we compute for our dot product of A and B? We found it to be 25. So 25 divided by the magnitude of A, which is the square root of 74, times the magnitude of B, which is the square root of 14. And then the next step would be to just plug this in your calculator, and whatever value you get, make sure you're in degree mode and not radian mode. You will get the angle. So I'm gonna plug it in real quick. So 74 square root times 14 square root Okay, so I got an angle of 39.04. So if you didn't get this answer right, you messed up somewhere. Or you might have not plugged it in properly in your calculator. But this is the angle between vector A and vector B. So looking back in retrospect, the first thing we do is find the dot product of vector A and B. So basically just multiply each component, each x component, y component, and z component. And in doing so, you get a scalar value. In this case, I got 25. Next step is to find the magnitude. So I found the magnitude by taking all the x, y, and z components, squaring them, adding them together, then taking the square root. You should get another scalar value. In this case, I got the square root of 74. The next step I did was we did the exact same process, but we found magnitude b. So whenever we did that, the x component of b, y component of b, z component of b, we square them, add them together, take the square root. We got the square root of 14. Then we solve for theta using this formula right here. Cosine theta is equal to a dot b divided by magnitude a magnitude b. We solve for theta. We take the arc cosine of our three values. We plug them in. And then we get this answer. And that's how you find the angle between two vectors. Thank you for watching. I hope that was helpful.
Yeah.